Today's lesson, we are in 6.4, proving triangles similar by AA. And from proving triangles congruent previously, you will remember that A stands for angle. So this is why angle, angle, angle didn't work, right? Angle, angle tells you that two triangles are similar. And notice we only need two, right? Because if we have two, we technically know the third has to be equal, right? But we don't even need to know that. Just by having two, we know triangles must be similar, and that's going to be the number one way you will prove triangles similar, right? The other ways of proving triangles similar involves acquiring, knowing numbers so that we can say things are proportional, right? So, starting off, determine if the triangles are similar. If so, write a statement, right? So I've got a 90-degree angle, and then I'm missing an angle from each, so I need to do 90 minus 26 to find that third angle, which is going to be 64 degrees here. And now that I found my third, we do have a second match, and so those triangles are going to be similar. So yes, and then it wants us to say angles, right? These three triangle, these three letters similar to triangle, these three letters. Right, so I'm going to go 90, 64 to the other angle, so that would be DEC. Similar to 90 to 64, you got to do the same order, GHK. So DEC, similar to GHK. On this bottom one, we don't have any numbers, but parallel tells me alternate int. This is also alt int, and we have vertical in the middle. Right, so this one is also a yes through alternate interior angles. And then we've got them labeled for a reason. So 1, 2, 3, 4. And so I'm going to say triangle SRB is similar, right? So we're just one squiggly to UTV, right? Because we got to do the one congruent, two congruent laugh, one congruent, two congruent laugh. So that is one way. You could also say RBS, TBU, right? So there's different ways to say it, but it is important that angle S and U must be congruent for that statement to be true. Angle R and T must be congruent for that angle to be triangle to be congruent. And then in this case, RBS and TBU must be congruent, right? Moving on. Given, we've got perpendicular and one angle already congruent for us. Prove triangle ABC, large triangle, is similar to the medium one. So the medium, the whole thing is the large. So, fill in your given. CD perpendicular to AB, BC perpendicular to AC. And then we also have angle A and BCD congruent. Says 4, but it might be more than 4. So let's see here. Okay, so we got this large triangle. They're telling us this is a right angle, right? From the given, BC perpendicular to AB. But looking at it, right? So because they're similar, we can have some overlapping here. So we'll get out the highlighter. This triangle, similar to this triangle, right? Now, the green helps us a little bit, you see that overlap, but more so with the angle. Both of these triangles use angle A. So, angle A is congruent to itself. It's reflexive with an angle. And we haven't seen that much yet, so it's coming up right here. Now, secondly, normally we would talk about these angles being congruent, which are right angles, and right angles are congruent. It's going to get us beyond 4 steps, but I think this one is a 5-step anyway. So step 3 is going to be we've got some right angles there, right? Angle ADC and angle BCA or ACB, however you want to say it. We'll say BCA are right angles. Definition of perpendicular. And then, therefore, they're going to be congruent angles, because all right angles are congruent. Fortunately, hypotenuse leg does not work this way, so it does help to know that every time we see perpendicular here, we can just go straight to perpendicular means right angles congruent. And there's my second angle. So the triangles are similar. Again, that was AA. And then we've got ABC and ACB. And that wraps up that proof. Another one, determine if it's similar. And again, don't forget, that's 92, so I just need to figure out this angle to see if it matches 58. 90 minus 32, because again, it's normally 180 minus, but we know since it's a right triangle, the smaller one's added to 90. Ooh, that one's also 58, and so now I have my second angle congruent. Right angle is congruent, so this one's a yes. And the similarity statement is again triangle similar to triangle. I like to start with my right angle, so FBC, right angle to my 58 is going to be congruent to right angle to my 58, so FEB. If you have to, the alternative is to go with the triangle and say, okay, angle F congruent to F. Now, normally we won't say this, but just a little note, this is for naming our triangle that are similar. And then we know angle D is congruent to angle E. Again, talking about if we just drew the triangle here, 58, 90, 32, and then drew the other triangles separate, right, of how we would name them. Because for similarity, we just need the 3 letters, right? We don't want a 6-letter triangle that was goofy. Lastly, 32 degrees is C, so angle D in that triangle must be equal to, and that's kind of what I'm talking about where we go down this FDC similar to FED. Okay. And that was also a way that we did our congruent statements, but we know in this case they are not congruent. Next one, we're proving cat is similar to dog, and we've got a couple parallel lines. So, as always with parallel lines, at least since chapter 3, parallel lines lead to angles congruent. Now, if you didn't like the angle section in triangles congruent, you might not like these, because this is basically more of the same. But label we got CP parallel to DG. So what angle is congruent there, right? If we extend our lines a little bit, we get this angle and this angle. So angle D and C are alternate interior. So C and D are congruent by alternate interior angle. Next up, that was my first given. Now I'm going to do AT and OG. So again, similarly, how are those angles congruent? Right here, changing colors up, we've got these 2 angles are congruent, but this is the interior for that one. So these are alt X. So 3 angle, we got to use 3 letters here, angle TAC, or we can call that angle cat, I suppose. Angle cat is congruent to angle dog, because those were alt X angles. And now I have 2 angles, I'm done. The nice part of these is that you only need 2. So triangles are similar, restate your proof, cat and dog. By angle, angle. Moving on, we've just got a couple more left. So other proportion problems are a woman who is 5'4", half the shadow is 4 inches long. And how long is the shadow of a child who is 58 inches tall? So again, this was how tall the woman was. And that's going to be across from how tall the child is, but you want to convert it into inches. 12 inches in a foot gives a 60. 60 plus 4 is 64 over 40 is the woman, right? Bottom shadow, top the actual height. With the child, we've got his shadow is, don't know, he's 58 inches tall. So maybe not the youngest child here. over how long is his shadow. And this is a cross multiply and divide. Might not necessarily be a nice number, so this would be suggested to use your calculator. 64x is 58 times 40, and then divide by 64. Now this is what I'm talking about by using your calculator. I'll wait till we're all the way at that point before I break out the calculator and then plug it in. 58 times 40 divided by 64. And somebody has even said you could have simplified 64 and 40 to be divided by 8 divided by 8. But it's all right, the calculator doesn't work at the end. Again, the shadow is 36.25 inches for the child. A couple more proofs left. This is a proving lesson. 3 steps. Triangles are similar. Go ahead, try this on your own. How can you get 2 angles in 1 step? And this is a diagram that we've seen before in this lesson. So I'll fill in the freebie. And in this lesson, you already know it's going to be AA. So you basically have 1 step to fill in. And you got to use parallel. So these are congruent, and that's what you need to write about. So G and K are congruent, F and J are congruent angles. All those are alternate interior angles. Congruent or theorem, and that is that one. If you need more time to write these down, you can always pause. And now this is just getting to the point. It's very similar to one of the earlier ones we did, but our proof's different. And that proof literally comes from definition of similar triangles. So let's see what we got here. They're saying AD to CD is similar to CD to BD. So what triangles, 2 triangles use those? We need to show that this triangle, didn't finish my 3rd side here, is similar to this triangle. So this one's going to be a pretty quick one in terms of similar, because we've got an angle given to us, and we've got perpendicular. We're literally going to focus on why those perpendicular angles are congruent. One in the freebie. Given. So 2 is we've got angle CDA and angle BDC are right angles. Hold on, maybe I'll do it the right way. CDA, BDC. Actually, that is the right way. Meaning setting myself up so that I can say those triangles are similar in a quick minute here. Those angles must be congruent, because that's what we're going to see now when we see perpendicular. If we're not doing triangles congruent, right? All right angles are congruent, or right angles congruence theorem. Right? This one was already ready to go here, so we just needed these 2, so we're set. So angle, triangles are similar. And again, triangle CDA is similar to triangle BDC. Slap here. And then from this statement, we can basically say long leg to long leg is similar to short leg to short leg. This leg is the long leg of the small triangle and the short leg of the medium triangle. So that AD to CD equals CD over BD. And that is, right, we got geometric mean involved there. And that is definition of similar triangles. Or figures. We'll go with figures, like polygons. Right? Because by definition, all angles are congruent, and we already used 2 of the 3, right? And all sides are proportional. And that's what we did. We created a proportion from the sides. And that wraps up this lesson. Let me know if you have any questions by email.